Here we go. This is the tutorial to do the flathead screw. Now, your team needs to decide some design considerations. I made some assumptions for my model, but it's your design problem to decide how thick to make the bottom plate, and that will affect the length of the screws you make. Since this tutorial, I've decided what thickness I want the plate to be, but I haven't told you. So you'll need to make sure that when you design your assembly with your team, that you decide to make a fastener that will meet the design which you make. So it might be slightly longer than that. But this tutorial should give you the basics of how to approach this part. So the hole size in the movable jaw is a 1/4 inch hole, 1/2 inch deep. The fastener is going through the plate on. So we're going to reference our chart. So as you can see, the overall length of the flathead screw is from the top of the head to the tip. So the length that actually goes through your plates would be the dimension L minus H. Alright, so what I'm going to do is I'm going to start as I typically do. We're going to go world coordinate system, and we're going to model in the front view. And I'm going to start drawing a couple lines that will start on origin. In both directions. Once you pick up origin, I would turn off the grid snap. Okay, so we're going to put the head on this side, thread on this side. Let's start with the head, and we go back to our chart, and a 1/4 inch diameter flathead screw. The A diameter is the diameter of the head. So we're going to look at A, and it's actually for a sharp flathead, it's a 1/2 inch in diameter. So we're going to offset 0.25, which is 1/2 of a 1/2 inch, off center line. Looks like my scale is pretty far off, so I'm going to zoom in. Now I'm going to trim my piece, and this is the top corner of our angle. Now we're going to offset this line by the dimension on the height of the head, which again is H. H on this chart is 0.14. So we'll offset 0.14. Which gives us the height of the head. Okay. Now I'm going to offset for the major diameter. Okay, it's a 1/4 inch, but we're doing 1/2 of that, so it's because we're doing a radius. 0.125 and offset center line up. Now in theory, if we connect this point and this point, that should be our flathead angle. We then should be able to trim off the unnecessary legs of the line. We'll leave this vertical one here for now. Now, I've calculated the plate I'm going to make is I'm going to need a 1/2 inch plus an 1/8 inch. That would be 5/8, nominally 5/8. Now I've got 140 thousandths here, so I need to add that and round the next fractional size. And again, you need to decide how long your fastener needs to be. So if I start with a 1/2 inch for the hole, and I'm approximating, I'm going to go through another 0.125 of material in my plate, and then I add H, which is 0.14. That gives me a fastener of 0.765 long, which I'm going to say is close enough to a 3/4 inch overall length. So I'm going to do an offset of 0.75. I'm going to offset from the top of the flat to the end of the fastener, because that's how they're sized. At this point, I can delete the outside line, and we can trim off the other ones. Okay, I don't need this vertical line here either. Alright, so let's go to a home view, and I guess I have an erroneous line out here I don't need. So at this point, I need to take and type the join command, and I'm going to join all of these features into one entity, which will allow me to revolve it. Now we're going to go to the solid command, revolve. We're going to select our profile. We're going to hit enter to accept the profile, and then it's going to ask us what axis we're going to revolve around. Mine's drawn in line with the x-axis on center line, so I'm going to type X. And now it's asking how many degrees you want to go. I'm going to go 360. And that should be the base shape of the actual screw. Okay, so like I said in the instructions, you can make this any drive type you want. I'm going to make it slotted since that's one of the easiest. Let's see if our chart gives us any information on that. Yeah, J, the slot width, and slot depth is T. So we have a slot width of 0.075 maximum with a depth of 0.68 maximum. Okay, so we'll go back to wireframe, and we're going to look at this from the front view. And I'm going to switch the construction layer so you can see what I'm drawing. And I'm going to draw a line from origin all the way to the left. And draw another line from origin up to the top. And our chart said that we could be a width of 0.75 maximum, so we'll do an offset of 0.075 divided by 2, because we're doing a off center line, gives us 0.0375. So we're going to do an offset of 0.0375, and we'll offset the cyan center line in both directions. We're then going to offset from the end 0.068, which was the maximum depth to the right. And so we're going to close up this rectangle using extend and then trim up. The box. Like for some reason that didn't want to extend. There we go. And we don't need the line that's on center. So we'll now use that profile. Okay, we're going to go to draw. We're going to make a region. You gotta be kidding me. We're going to go and do an extrude. We're going to select the region. We'll go out, whatever that is. Alright, I'm going to try a different little trick. I'm going to go and I'm going to hide the model. And then it'll allow me to do a press pull on the end. And we'll go out another arbitrary amount. And we'll go and make the model visible again. Alright, so we have like a key that we can use. And we're going to do a body subtract, select the screw, accept that selection. We're going to remove the cyan part, and that leaves us with our slotted head screw. Okay, now we're going to set up for the thread, and I'm going to make this one fully threaded, which means it runs right up to the head. Okay, so I'm going to create a line. We're in the front view, which is good. We're going to go from center to center, and that gives me a line right on center line. Now I can offset for our major diameter, which is 0.125, so it's half the quarter-inch diameter, and then we'll offset that line. Now we need the minor diameter. I'm going to go to my chart, and we're going to look at the screw thread chart. And for a quarter 20 thread cores, the exterior thread minor diameter is 0.1905. So we get our handy dandy calculator out again, 0.1905, and divide that in half, so we've got a radius. And that was not right. We take 0.1905, divide that by 2, and it gives us 0.09525, which is our offset from the center line. Okay, so we're going to offset that mount. And offset up. So that gives us the difference between the major and minor diameter in a thread. And I'm going to create a line on the endpoints of that. Now I want to offset this line by the thread pitch. So the offset should be 1 divided by 20. Threads per inch is 0.05, so 50 thousandths. And I offset the other line. Now I'm going to use a method where I extend the lines on the top and bottom, and then I'm going to trim those off. Okay, we're going to rotate this part 30 degrees, which gives us part of our thread. We're going to go and then repeat that on the opposite side here. Base point will be here. We're going to negative 30. Now we're going to extend the lines out. Now our pitch is not from sharp to sharp in this in the United National Fine or Coarse series. There's actually a flat, and the crests are a theoretical point at the top. So right now we have ours a little too far apart by half. We're going to split this flat between the root and the top. So a quick way to do that would be to use the move command to move the line on the right, and we're going to go from endpoint to midpoint, and we've now split the difference. Trim off the tails, and you now have this shape to drive around for that particular thread size. We're now going to type join, and we're going to select the profile of the thread to make it all one piece. Okay, so now all we need to do is do the helix. So we're going to go up to draw, and we're going to select the helix command. Looks like a coil. And it's asking us to specify the center of our helix. So we're going to pick the right side of our cyan line we have. And we need to make sure that we're in first world coordinate systems and then the right side view. We want our coil to be in that diameter of the right side view. So now we're going to go to draw. We're going to select helix, just like coil. And we're going to select the right hand end of the cyan line we have there. And now it's asking for a diameter. We're going to select the diameter of this end to match the top end of our profile we're going to do our cutting with. Now it's asking what our second diameter is for the helix itself, and we want it to be the same. So it's going to be 1/4 of an inch diameter, or 0.125 radius. Okay, so now we have the correct radius. And now we need to check the twist. So we want a right hand thread, which would be clockwise. Type W. And we're going to go CW, which is clockwise, which gives us the correct spiral. Now we need to set the spacing. So that would be under turn height. And the value you're going to put in there is the thread pitch, which is 0.05. And that gives us the correct spacing for a 1/4 inch thread. And now you can select the opposite end of the line we drew for the length of the thread. We now have the helix path to drive our shape across to do our cut. Before we do that cut, we want to put the chamfer on the front of the screw. I left it sharp intentionally so we could use it for construction, but now we do want to put it on there before we cut the thread itself. So go to the solid command, we're going to do chamfer edge, you're going to pick the front of the solid, and it's defaulting to some gigantic chamfer. You're going to type a D for distance, and we're going to put 0.01 by 0.01, and we should have a realistic chamfer at that point. Now we're ready to do our sweep. So go to home, select down on extrude, we're going to select sweep. It's going to first ask you the profile you want to use as your cutting tool. We're going to accept that by hitting enter, and we're going to type A for alignment, and it's asking is it perpendicular to the path, which it is not. We're going to hit no. And then provided you drew your profile, made it up, that's intersecting the actual path in the correct orientation, you don't have to do anything else but select the coil. If they're not lined up, you need to select the base point of the corresponding corner of your path. So select the coil, and the helix, and it's creating a solid body that is in cyan. Okay, we're going to use that body to cut the screw. thread. So now we go to a solid subtract, select the main screw body as the piece to keep, hit enter, and then we want to select the cyan body that's the cutting thread and hit enter. And it should have removed away, and we have a screw thread that looks like so. The end looks funny because of where the thread starts. Now again, you need to use design thinking to set the proper length for this screw. That's it. That's the third tutorial, and that is to teach you how to do the flathead screw.